In this video, I will show how to solve a radical equation, and let me remind you that to solve a radical equation, we have to isolate a radical expression first and then raise both sides to the appropriate power. So the radical expression here is square root of p plus 4, and this is the reason why it's called the radical equation. And to isolate it, we're going to add p and subtract 2 from both sides. So as a result, we have this equation, and next we're going to raise both sides to the appropriate power, which is 2 in this case because we have a square root. Now raising square root to the power 2 eliminates the radical, but the right hand side actually has to be squared. So p minus 2 squared is p squared minus 4p plus 4, and as a result we don't have a radical equation anymore. In this case we have a quadratic equation, and to solve this quadratic equation we're going to first write it in standard form. So I'm going to subtract p and 4 from both sides, and I'm going to write the right hand side on the left and the left on the right. So the result of combining all the like terms on one side is p squared minus 5p equals to 0. We can factor this quadratic expression, and we can use the zero product property to solve this quadratic equation. Now, since we're solving a radical equation, we always have to remember to check for extraneous solution. So the easiest way to check is to just take each value and plug it into the original equation to see if it turns the equation into a true statement. So when you plug in 0, we have square root of 4, which is 2 minus 0 plus 2 equals 0. That's not true. So 0 is not a solution. We call it extraneous solution. Now p equals 5 gives us square root of 5 plus 4 minus 5 plus 2 equals 0. Square root of 5 plus 4, it's square root of 9, which is 3. 3 minus 5 plus 2 is 0. That is true. So the only solution to the original radical equation is p equals 5.